Today's lesson is on isosceles and equilateral triangles and the relationships between their sides and their angles. Right away we're given that ABC is isosceles and that AB is equal to BC. So this side length equals this side length. We aren't given anything else, but we are trying to prove that angle BAC is equal to angle BCA. Now, we don't have any information to show us that, so I'm going to have to show you guys a technique that is outside of your toolbox, something that I wouldn't expect you guys to know how to do, something that I just know how to do just from previous experience. And the fact that we've been working with two triangles and trying to prove that two triangles are congruent. Right here, we only have one triangle. So what I'm going to do is split this in half by drawing the angle bisector of angle B. And we're going to call this line BD. Now, what we're saying here is this is another given, is BD bisects angle B. So it cuts angle B in half, and what we then know is that this angle is equal to this angle because they're both half of the original. So I'm going to start with my statements and my reasons. Start with AB equals BC. That's given. Then I'm going to say that BD bisects angle B. That's given. And then I'm going to say that angle ABD is congruent to angle CBD because that's this angle and this angle, because of the definition of angle bisectors. Good. Now we have a side pair, an angle corresponding pair, and then what you see is that this side right here is shared by both triangles. So we can say that BD is equal to BD, or congruent to, and that is the reflexive property. From that information, if we start on just the left triangle, we have a side, and then we move over, we have an angle, and then we have a side right there. So triangle ABD is congruent to triangle CBD because of the side angle side congruency theorem. And then we're trying to prove that this angle is equal to this angle. Well, they are corresponding parts of congruent triangles. So that's going to be our reasoning. Corresponding parts of congruent triangles are congruent. And we say angle BAC is congruent to angle BCA, and we're done. So that is the proof that if we have a isosceles triangle with equal sides right there and there, that the angles that are across from the sides are going to be congruent also. And when I say across in a triangle, so across in a rectangle or a square, across from this side is another side. Across from the bottom is the top. But in a triangle, across from it is an angle. So across from this side, go right across there, and angle. So that's why we say that the isosceles triangle theorem states that if two triangle sides are congruent, then the angles opposite those sides are congruent. This angle and this angle. The converse says that if a triangle has two congruent angles, these two, then the sides opposite those angles are congruent. Right there and there. The isosceles angle bisector theorem states that the bisector of the vertex angle is also the perpendicular bisector of the base. So, if these sides are equal, the angle bisector cuts it right in half, meaning that both these angles are 90 degrees and that the base is cut in half also. Corollary equilateral triangles. If a triangle is equilateral, then it is equally angular. So, stating that if we have equilateral, all three sides are equal, then all three angles are equal. And then the backwards version, or the converse, is that if we have equally angular or equal angles, then we can assume that it's equilateral also. And what we know is that all three, being the same angle measurements, have to add up to be 180. Therefore 3x equals 180. X equals 60 degrees. So in an equilateral triangle, all the angles are equal to 60 degrees. Now I'm going to do a couple examples for you. Find the values of x and y. What we know is that if these two sides right here and right here are the same length, but this one isn't, we know that that angle is going to be congruent to that angle. So if this is x, then this is also x. And looking at the right angle, don't even look at the left triangle at all. We know that 50 plus x has to equal 180 degrees. So 2x plus 50 equals 180. Do the math, subtract 50, you get 130. 2x equals 130. Divide by 2, x equals 65 degrees. Same thing with the right side. The left side. If we have an angle that's 100 degrees and that this side and this side are equal, then both of those angles are y. They're going to be the same length. If you solve it the same way, you're going to get y equals 40. Moving on. Okay. We see that this angle is 90 degrees total. And we see that this part of it is 28 degrees. So the other part would be what plus 28 equals 90? And we see it is 62. 62 plus 28 equals 90. Or you could say x plus 28 equals 90, subtract 28, subtract 28. Either way, you still get 62. Now, if this is a isosceles triangle right here, we know that this being equal to this, that means that this angle is equal to this angle. So this also is 62 degrees. And now we know that 62 plus 62 plus x, all those angles inside this triangle, have to equal 180. So that is actually 124 plus x equals 180. It's a plus sign right here. And then subtract 124 and you get x equals 56 degrees. Moving on. This one's just a little bit trickier. What you realize is that this angle right here is 48, and that this angle, along with that 148 degree angle, have to add up to be 180. So you say x, sorry, we'll call that y, because we already have an x on there, plus 148 equals 180. Subtract 148, and you get 32. So y equals 32. Then what we see is that angle y, and we'll call this angle z, they have to add up to be 90 degrees because that's a right angle right here. So I say 32 plus z equals 90. Subtract 32 and you get z equals 58. Now if this is an isosceles triangle and these two sides are equal, then that would make it so that these two angles are equal. If this is 58, then this is also 58. And what we see is that this angle, being 58, and this angle, our unknown x, have to form a straight line. So they are supplementary and they have to add to be 180. So then you say, well, 58 plus x equals 180. Subtract 58. And x equals 122. Go ahead and do the rest on your own, asking for help. And that is the whole question.